Hello children, welcome back to my channel. I have done SSC important questions, application of trigonometry, 2 marks, 4 marks, 6 marks. Now we will do objectives. A ladder 15 meters long, a ladder 15 meters long, a ladder 15 meters long is just reaches the top of vertical wall, the top of vertical wall if the ladder makes an angle of 60 degrees with all, an angle of 60 degrees with wall, then the height of the wall is, then the height of the wall is dash. What is this? A ladder. Let us consider this as a ladder, A, B, C. This is a ladder. Ladder is 15 meters long. It just reaches the top of the vertical wall. The ladder makes an angle of 60 degrees. Now find the height of the wall. H is how much? So we know that tan 60 degrees is equal to H by 15. Root 3 is equal to H by 15. Therefore, H is equal to 15 root 3 meters. So the answer is 15 root 3 meters. This is first one. Now second one, a 20-meter long ladder is placed. A 20-meter long ladder is placed on a pole of 10 meters height, making alpha angle. Making alpha angle with the ground. Alpha angle with the ground. Now the question is, then alpha is equal to dash. So what is the problem says? A 20 meters long ladder, this is a ladder, is placed, ABC, is placed, a 20 meters long ladder is placed on a pole of 10 meters height. This height is 10 meters and it is making an angle of alpha. So what is alpha they are asking? See, this is opposite side by hypotenuse. That means sine alpha is equal to 10 by 20. That is 1 by 2. Sine alpha means we know that sine 30 degrees is 1 by 2. Therefore, alpha is equal to 30 degrees. This is the answer, children. Please copy it. Now, third problem. A ladder touches a wall. A ladder touches a wall at a height of 5 meters. At a height of 5 meters. The angle made by the ladder, the angle made by the ladder with the ground if its length is if its length is 10 meters will be dash. A ladder touches a wall at a height of 5 meters. This is height of 5 meters, and a ladder touches the wall at a height of 5 meters, and the angle made by the ladder with the ground if its length is 10 meters. The ladder length is 10 meters. What is the angle made? So we know that tan theta is equal to AB by, here sin theta we have to take. Opposite side by hypotenuse, no? Sin theta is equal to AB by AC. That is equal to 5 by 10, 1 by 2. So just now we have done sin 30 degrees is equal to 1 by 2. Therefore, theta is 30 degrees. So the angle will be 30 degrees. Fourth question. The angle of depression from the top of a tower 12 meters high 12 meters height at a point on the ground is 30 degrees. The distance of the point from the top is dash. The angle of depression from the top of a tower, there is a tower. The angle of depression from the top of a tower 12 meters high, tower height is 12 meters, at a point on the ground is 30 degrees. So this is a point, this is 30 degrees. That means this is 30 degrees. So let me consider this as ABC. Now the question is, the distance of the point from the top is, from the top means from here to here, the distance they are asking. That means this is opposite side, and this is a sine 30 degrees. We need sine 30 degrees is equal to opposite side, that is 12 by AC. Sine 30 is 1 by 2 is equal to 12 by AC. 12 by AC. So what is AC? AC is equal to 2 into 12, 24 meters. So the answer is 24 meters. The distance from the top of the town. The question is the distance of the point from the top. Top means from here to here. So here to here means hypotenuse. Opposite side by hypotenuse. So this is the fourth one, children. Next, fifth question. If the angle of elevation, if the angle of elevation of the sun increases from 0 degrees to 90 degrees, then length of the shadow what will happen? They have shadow of the tower, shadow of the tower. What happens? This kind of problem we have done, children. The length of the shadow of the tower decreases. I have explained on that day when I have done by making different angles. I have explained. So always when the sun rays angle increases, then the length of the shadow will be decreasing. So write down this, children. Now we'll see sixth problem. Top of a building was observed. Top of a building was observed at an angle of elevation, at an angle of elevation alpha from a point which is at a distance of which is at a distance of which is at a distance of d meters from the foot of the building, foot of the building. Which trigonometrical ratio? Which trigonometrical ratio? Trigonometrical ratio should be considered. Should be considered for finding height of the building. For finding height of the building. Height of the building. For finding height of the building. Now the question is, top of a building was observed at an angle of, see, this is a building top. It is observed from a point C. Top of a building was observed at an angle of elevation of alpha. So this is alpha. Okay, alpha from a point which is at a distance of d meters. This distance is d meters from the foot of the building. Which trigonometrical ratio should be considered for finding height of the building? So you want height. How will you find out this? It is nothing but tan. Tan alpha is equal to h by d. So which one we will use? Tan alpha. So we'll be using trigonometrical ratio as tan alpha. So I hope I am clear, children. Now we'll go to the seventh one. Seventh one. Two persons A and B. Two persons A and B observe the top of a pole at an angle of a pole at an angle of elevation alpha and beta respectively. If alpha is greater than beta, then which point is who is nearer to the pole? Which are correct? You have got 4 points, children. First one, A is nearer to the pole from A is nearer to the pole than B. This is the A bit, and B bit. B is nearer to the pole. B is nearer to the pole than A, and C bit is AB are same distance from the pole. A and B are at the same distance from the pole. This is C bit, and D bit is can't compare their distances. Can't compare their distances. So let us draw the diagram, children. Two persons A and B observe the top of a pole. So this is like this. One is A, one is B. They are observing the top of the pole like this. Now what are they saying? The angle of elevation is alpha and beta, and alpha is greater than beta. Definitely this will be alpha and this angle will be beta because this angle is lesser. So when alpha is greater than beta, the distance A is nearer to the pole than B. So the first one is correct for this answer, children. Please note down. This is seventh one. Now eighth one. A ladder X meters long. A ladder X meters long is laid against a well. Is laid against a wall. It is not well, against a wall, making an angle theta with the ground. Making an angle theta with the ground. If we want to directly find, if we want to directly find the distance between the foot of the ladder, the distance between the foot of the ladder and foot of the wall and foot of the wall, which trigonometric ratio should be considered? Which trigonometric ratio should be considered? This is the question. A ladder X is laid against the wall. This is wall and this is the ladder that is made. This length is X meters with an angle theta. This is angle theta with the wall. If we want to find directly the distance between the ladder and the foot, what is this distance you wanted to find out? Distance between the foot of the ladder and this. Then which trigonometric ratio should be consider. If you want this x, see this is adjacent side by hypotenuse. That means cos theta is equal to x by x. Therefore, what is the answer here? Cos theta. We are using the trigonometrical ratio is cos theta. Next, we will see the ninth one. In the given figure, BC is equal to 20 meters, AC is equal to 10 meters, then theta is equal to dash. Figure is given like this. Here A, B, C. BC is 20 meters, AC is 10 meters. This is theta. So actually what is this theta? Opposite side by hypotenuse. So sin theta is 10 by 20. So this is 1 by 2. So we know that sin 30 degrees is equal to 1 by 2. Therefore theta is 30 degrees. So the answer is 30 degrees. Please cooperate, children. With this, application of trigonometry topic is completed. In the next class, I will be doing another topic.